Hello everyone, good evening.
Good evening.
Good evening, sir.
Good evening, sir.
Good evening, sir.
So,
Good evening, sir.
have you all covered week 5 content or still in progress?
Yes, sir, completed.
Yes, sir.
Yes,
There are
sir.
only 2 lectures, right?
Just graded assignment left.
So you will be more clear with this, like as you move forward to week 6, because week 5 and week 6 are very linked in some sense. You will find it as soon you cover week 6. So, okay. So today we have solved with this session for week 5. Okay, so those, I think most of you are aware of this instruction now. But for those who are new, just keep a copy and pen with you to solve. For each question, you will be given 5 to 10 minutes. And to answer the question, you have to open in a new tab or in a new browser. You have to go to joinpd.com and enter the code seen written on the right top of the screen, which is QYZJUS. I will type it in chat as well, so you can copy. The result for qualifier students has been released also. So how was the result for you all?
Sir, I can't see now.
You appeared for qualifier this term or have already cleared it?
Yeah, this term only, 5th June.
Okay, and for others also it's the same or?
Yes, sir.
I had qualified way before.
Same, sir.
Okay, I think it will be released again. Yeah, it will be made available for. Okay, so if you are using laptop and desktop, so your view on joinpd.com would be something as shown on the left side of the screen. You will see the question and options to answer side by side. But if you're using it on mobile, you have to click on the right bottom of your screen. There will be an option to answer question. You have to click on it and then input your answer. Okay. Okay, so moving forward, question 1. So Tom has 6 different cars, okay, and he planned to go on a ride for the next 4 days. And he decided not to use the same car twice. So if he used the car on day one, he cannot use that same car on other days, day two, day three, and day four. So in how many ways can he select the cars to go on a ride for next 4 days?
Done, sir.
Done, sir.
Okay, let's move to the solution for this one. Okay, most of you have 1 to 360. Okay. Okay, great. So Tom has to choose one car for each day, right? So on the first day, he can choose any of the 6 cars he has. Then for the second day, he can choose any of the remaining car except the one he used on the first day. So now he has 5 options for the second day, right? Similarly, for the third day, he can choose any of the remaining car except the ones he used on the first day and second day. So he has 4 options to select a car on the third day. And similarly for the fourth day, he will have 3 options. So here it's occurring like simultaneously. So you will have to use the principle of multiplication rule. Okay. So the total number of ways of selecting it would be 6 times 5 times 4 times 3, which is 360. Any doubt in this? Anyone?
No, sir.
No, sir.
So the question was like he won't repeat the card twice, right?
Yeah.
No.
Same car
Yes.
twice. Yeah.
I thought it was like 2 days the same car.
Yeah, that's what it means. Like he won't be using the same car twice. So if he has used a car on any of the days, day 1 or day 2, he won't use that car on day 3 and day 4. Something like that.
So yeah, like the third day he will have 5 options, right? Like the
No,
2
no,
days are over, so one car can be used again and one car cannot.
no. He has, let's suppose these are the 6 cars he has, right? 4, 5, 6, 6. Okay. He used C2 on day 1, right? And C4 on day 2. Then for day 3, he will have only these 4 options, because if he use C2 again, it will be the same car used twice. And it is mentioned in the question that he decides not to use the same car twice.
Okay, okay.
If it had been that he cannot use the same car twice in 2 consecutive days, then it would be the statement which you understood, right?
Okay, I get it. So he won't use the same card for the 2 days. Like next day he won't
2
use it.
consecutive days, yeah. Then it would be like, yeah, for
Yeah,
third day he would have 5.
Yeah, I got it. Yeah, thanks.
Okay. Anyone, any doubt in this? Shall we proceed further? Okay. Okay, so it's the same question again, but now he can select the same car on different days. So if he's using a car on day 1, he can use it on day 2 and on day 3 and on day 4 also. So he's allowed to use the same car on different days. Okay, let's. Do you guys need more time in this, or we can move to the solution part?
No, sir, done, sir.
Done, sir.
Okay, so most of you have answered 1, 2, 6. Okay. So yeah, so for each day, yeah, he will have 6 options, right? So on the first day, he can choose any of the 6 cars. Then on the second day, he can also use the same car or any of the other remaining 5. So for second day also, he will have all the 6 options to take the car. Similarly, on third and fourth day, each he will have 6 options. The total number of ways that he can select cars for next 4 days to go on a ride would be 6 raised to the power 4, which is 1296, right? Any doubt in this?
No, sir.
Okay, yeah. Let me also introduce you to the EMQ part. I think it would be week 6 and you will be saying. Good. So do you guys know what is the simultaneous occurrence of events?
They occur one after the other, like sequential.
One after the other. And so in this question, when we have to select the car for 4 days, was it simultaneous or not simultaneous?
Not simultaneous.
Not simultaneous, why?
Yeah.
It will be simultaneous, right? Because when you are computing the total number of cases, you first
Oh, yeah, we are multiplying, right?
you are selecting the options you have on day 1, right? Then you are selecting the options you have for day 2, then you are selecting day 3, day 4, right? You are doing it all at the same time. You are not, it's not like either this will happen or this will happen, right?
Yeah, yeah.
You're doing it all together. So it's the simultaneous occurrence, right? Okay. In this question, was the question with repetition or without repetition?
With
This is
repetition.
with repetition.
With repetition, right? And does order matter over here or not?
Order doesn't matter.
Order doesn't matter. Why? So suppose I take C1 on the first day, and then suppose C1 on the first 3 days, and then C2. Now, if I take C2 on the first day, then will it be different cases or the same?
Same cases.
Different cases, sir.
Different, right? Because on day 1 I'm choosing different cars.
Yes.
So here order do matter, right? The order in which I'm picking cars for respective days. That's how you are getting 6 times 6 times 6, right?
Sir, can you please explain again this?
Okay. Which part? Order part or all 3?
Order part.
Okay. So for this question, you have computed answer to be 6 raised to the power 4, right?
Yes, sir.
So this was your day 1, day 2, day 3, and day 4. So on first day, suppose you have taken C1 car. Okay. Then on the second day, you have also chosen C1, then C2, and then C4. This is your car 1, car 2, and car 4. Okay. And suppose another possibility could be that you have chosen C4 on the first day, C2 here, C1, C1. So are these two same or different?
These two are different, but sir, for each day we have 6 possibility. So answer will be the same for both.
No. See, you have said that there are 1296 cases in total, right?
Yes, sir.
So I'm saying that this could be the one of the case of this 1296, right?
Yes, sir.
This could also be a case of these 1296 cases. One cases of these, right?
Yes, sir.
So
So even
in
like
your
in the first question, the order will matter, right? Even the first question.
yeah, we will come to that also. So in this your calculation of 1296 cases, have you considered these two cases to be same or different?
Different.
Different, right?
Yes,
So
sir.
if you're considering it different, it means order do matter.
Okay, sir.
If C4 is on the last day or on the first day, it is making difference, right? Order of cars making a difference.
Okay.
So order do matter over here, right?
Okay, sir. Thanks.
But if we move to the
Can
first
it-
question,
With repetition or without repetition, order matters. In simultaneous occurrence, is that what you are saying, sir?
no, you have to just think logically in this case. What's happening? Are you
logically? पूछने खुशी मिलेगी.
so? Suppose in the first question, right? You are not allowed to use the same car twice, right?
Okay, sir.
For question 1. So was that simultaneous occurrence or not?
It was a simultaneous thing.
Simultaneous, right? Because you are filling all the 4 spaces at once, right? Okay, so that's simultaneous. Was it with repetition or without repetition?
Without.
Without, because you are not allowed to use the same car twice. So that was without repetition, right?
And even the order matters.
Okay, so in that case, you have computed that there are 360 cases, right? If I'm not wrong. So suppose this is your one case, C1, C2, C3, C4. Another one is the reverse of it. So will you consider these two to be different cases or same cases?
Different.
Different, right? So if you are considering it different, it means order do matter. Otherwise, the cars I have used is same in both the cases, right?
Yeah, both the questions order matters exactly.
Yeah, only difference for the repetition part.
Repetition, right?
Is it clear to everyone?
Yes, sir.
So what's the basically reason of finding it's ordered or not ordered, order matters or not matters? What is the relevance?
Relevance is then it is just the intermediate steps you think while computing the final answer to this question, right?
Okay.
If it is simultaneous occurrence, you will be multiplying that on first day you can have 6 possibility. Then if you're multiplying, it indicates that it is a simultaneous occurrence. Okay?
Yeah.
Then if you are doing 6 times 6 times 6, or you are doing 6 times 5 times 4 times 3, for this step you need to be aware of whether repetition is happening or not, right?
Yeah.
So that's the second step which you follow to compute. Then order matters or not. So you suppose I have these two cars, C1, C2 on day 1 and day 2, or I have C2 on the first day and C1 on the. So does it make difference on which day I'm using which car or not? So for that thing, you need to be aware of whether order matters or not, right? Only then you will consider them to be different cases.
Sir,
Yeah.
order, I think order mattered because of days. So because C1, C2, C3, C4 are different days. So that's why order matter, because if we put the C4 first, then days will different now, sir. So that's why order matter.
Yeah, that's why order matter, right? So these are the things you have considered while computing your final answer, right? These are the 3 steps which you follow basically.
So, sir, correct me if I'm wrong. Like if question ask, find out the first day, like day first probability. So how many ways on a first day he can choose the car? So it will be 6 on that question. And if he asked question asked for 4th day, then answer would be different on the first question. So that's why we can say orderments matter or not.
Or it's not like that. See, if you consider this question, it's like you are doing an arrangement of cars, right?
Yes.
If I ask that you need to select only 4 cars of the 6. Okay? Select 4 cars of 6. Okay. So in that case, whether you select C1, C2, C3 or C4, right? Or you select C4, C3, C2 or C1. At the end, you have selected only these 4 cars, right?
Right.
So these are the same cases.
Okay.
It doesn't matter on which.
So in this
count
instance, order doesn't matter.
Order doesn't matter, right? Because at the end, I need to select only 4 cars. So these are the 4 cars I have selected. It doesn't matter in which order I have selected.
So in the second question, it doesn't matter, right?
No, it's not the second question, this question. If I have to select only 4 cars out of 6, if that's another question. So you're getting an idea of when these are the 3 steps you generally use to solve any question of in week 5 and week 6, right?
Okay.
So these are the 3 steps also you will see in the week 6 practice assignment. There are 2 practice assignments which we have released and 1 graded assignment based on EMQ. You all got the announcement regarding it, right?
Yes, sir. We received a mail.
Sir, I have a problem with that
Yeah.
pill, that yellow pill and green pill that is given in the practice assignment. There is some given, and I have a problem with that. I
Okay,
can
we'll
solve that.
come to it. Yeah, after the slides we'll move to it.
Okay.
Okay, so that's another question. In a stadium during security checkup, okay, the security guard asks people to form 2 different lines for entry to the stadium. Okay. So assume that there are 7 people in the security checkup area. Then in how many ways can the 2 separate lines be created? Okay, do you guys need more time in this or able to solve?
Yeah, done, sir.
Okay, so most of you have answered. Okay. Okay, so if you like observe the question carefully, so each person has two options. Either he can go to line 1 or the line 2. So in general, each person has two possibilities, right? So the first person has two possibilities. Similarly, second, third, so on till the seventh person will also have two possibilities to either go in the line 1 or in the line 2. So the total number of possible ways to create two separate lines would be 2 times 2 times. That would be 2 raised to the power 7, which is 128. Is it clear?
No, sir. Like, I'm like thinking like if there are two separate lines, at least like one line should contain at least one person. So in that way, I thought it's
such,
6 ways.
such condition is not given, right? Okay, so how did you approach this one? Even if okay, so how did you approach this?
If
Yeah,
there are
like,
7 security persons, each will tell them to follow 2 rows.
Yeah,
So
in general, there are two
someone-
lines, right? Line
Can you
1
like,
and line 2, right?
show the question once again, sir? Like,
So the security guard asked people to form two different lines for entry. Just
yeah, please explain once, sir.
okay, so how did you approach this question? Like there were
Yeah,
two lines.
I was like, there are two lines. Let's say one line is minimum, which is one person. Other line has all the rest 6. So then
Okay.
5 people come here. There'll be 5 other ways according to from the first way. So
So
6
saying that
ways.
one comes here, then other
Yeah,
6
6
goes here.
comes. And
Two
that way
comes
6
here
ways.
first, right?
Yes, sir.
Yes, sir. That's how I approach it.
I also did the same.
3, 2,
Then 5, 1. I mean, yeah.
3, 4, right? Then
5, 1.
one line, 2, and then it would be 2, 5, right? And 6. 1, 6. 3,
First is 1, 6. I said, yeah.
5 over here, remaining to go here, 6 here, and 1, right? These are the things you do, right?
Yes, sir. Yeah.
Okay, so how many ways for this to happen?
One way.
Why one way? Would be
49, sir. I think.
Can be
Okay.
reverse as well. Okay.
okay. See, in general, there are 7 people, right?
Yes.
So any one of these 7 can go to line 1, right?
Yes, sir.
So in general, I can select any one people for
Out of
this.
7,
This
sir.
one sum I can fill in 7, right?
Yes, sir.
Remaining all goes to line 2.
Yes, sir.
I'm not making any arrangement here. Remaining 6 goes, right? It doesn't matter in a line that if P1, P2, P3 standing or P2, P3, P1 standing. It's still the same person standing in the second line, right?
Yes, sir.
Yes, sir.
Similarly, for the second one, you can select any 2 people of these 7 to go to line 1, right?
Yes, sir.
Yes, sir.
So on the first place, any of the 7 can come, and on the second place, any of the remaining 6 can come. But what would happen in this 7 to 6 cases is, suppose person 1 at the first spot and person 2 at the second spot, or person 2 at the first place and person 1 at the second. These two will be considered different cases, right?
Yes, sir.
So to avoid this duplicacy, we need to divide by 2. So that would be 21 cases, right?
Yes, sir.
Similarly, for now, and remaining 5 will go to other line. We need not to worry about that, right? Then for the similarly for line, if there are 3 person in line 1, again you will have to do the same thing, right?
Yes, sir. Total 35.
So, does that mean like the remaining 5 will just go like we don't need to consider like 5 factorial for that?
No,
Does that
see,
mean-
you have sent 2 peoples over here, right? So you select 2 from here and send it to line 1. Now you are left with only 5 people,
Yes.
and all the 5 need to go to line 2. So there is only one way that all the 5 will go to line 2, right?
Okay. Okay.
So that's the one way you can do. Another way to think of it is there are 7 people, right? P4, P7. So first person can either go to line 1 or line 2, right? He has 2
Yes.
options to go.
Yes, sir.
Similarly, person 2
Right.
also has 2 options, either to go to line 2 or line 1. So on, last person will also have 2 ways, right?
So this is like the simplest way to get it.
Yeah, so that would be 2 raised to the power 7 ways.
Okay.
And yeah,
Yes.
here 0 and 7. This is also a possibility that all the 7 people go to line 2 or all the 7 people go to line 1. That's also a possibility. It is not mentioned anywhere that at least one person will be there in the line. Right?
Sir, but that will include like
That
one
would be no
one
line, na,
one
sir.
line.
No, that's not landed. You can also have an empty line. No? It's, even if you go to suppose metro or airport checkup, there are multiple security checkups counter, right? It is possible that this line is empty and all the 5 people are standing in this queue.
Yeah, yeah.
So
Yeah,
whenever
yeah,
there would be
positive.
condition like no empty line, it would be mentioned in the question only.
So in this question, sir, we include empty lines, sir, or not?
We will include it is because it is just asking how in how many ways I can create 2 separate lines. It is not giving me any condition on the separate lines.
Okay, sir.
So simplest way to think of it as each person has 2 possibilities. So first has 2, second has 2, so on, 7th will also have 2, right?
Yes, sir.
Once we cover the week 6 concept, we will do the same question with a different method also.
Sir, why the order does not matter in this?
By the order, because I have to form 2 lines, right? So suppose my first line has P1 and P2, and or P2 standing in front of P1. It's still the same line, right? P1,
But
P2,
the
it doesn't matter.
sequence of line is different. In like the P2 standing behind P1 in the first line, and in the next P1 is standing behind P2. So this should be counted at 2 separate ways, right?
No, it doesn't matter in which order they are standing. P1, P2 is forming one line for me. That's all that matters. I have to form lines only.
Okay.
So in which order I place them, it doesn't matter really. These 2 are the one making line for me. That's all, right?
Okay. Okay.
Sir, what if there was a condition of at least one person in one line?
You will have that same question. So I think that may be the next one.
Sir, then
Yeah.
what does it mean by separate line?
Separate lines means, yeah.
Sir, I approach the question in the same way, like you explained, but in the end, I got confused over that 2 places, and I put 7 and next 6 that lead to me 42, and I think everyone does that. But here the separate line.
Yeah, 2 separate lines means you have 2 different and distinct lines. In other words, you can say.
So, in the end, the way you explained, doesn't it counted the same way when L1 in line 1 where it was?
No. Suppose I have these 2 lines, right? This is my first line. This is my second line, right?
Yes, sir.
In first line, I could have P1, P2, P3, and remaining 4, let's say over here. This is my one of the possibilities, right? If instead of
Yes,
this
sir.
P1, P2, P3, instead of this, they are standing in this order. P2, P3, P1. Then also it would be my same line, right? It doesn't matter in which order they are standing. It's the these 3% forming my first line, right? So I don't need to arrange them in between the lines.
Actually, we are looking for line, not for people. That's why
Yeah.
order doesn't matter.
Yeah.
Yeah, order doesn't matter. I just confused by that separate line term. That's all.
No, that's the same. Either you will see two separate, two distinct, or two different. It could be any word be used. Right?
Okay, sir.
Line 1 and line 2 should not be same. That's what it means.
Okay, sir. It's just like a multiple select question where one question has many solution, I guess.
Not mentioned. It's like not like, suppose it is a true false question, right?
Okay, sir.
So either
yes, sir.
Either you will select true or false. So two separate options, right?
Okay, sir. Now I visualize that.
Yeah, okay, so here
Thanks,
you
sir.
have to find the number of ways in which two separate lines be created, such that one of the lines should be empty. Okay, so in this question, you have to consider only the two cases of all the cases which you considered for the previous question, right? So yeah, most of you have answered it right. So the number of ways that first line will have 0 people and second line will have all the 7 people is only one way to get it right. Similarly, the other way it could happen that line 2 has 0 people and line 1 has all the 7. So in general, there are only two ways in which you can create two separate lines such that one of them is empty. Is it clear?
Yes, sir. Yes, sir.
Yes, sir.
Yes, sir.
So it was only these, just highlight.
The
These
first
are
and
the,
last one.
this case and this case. Now the question which you have assumed in the first one, you have to create two separate lines such that each line contains at least one person. So whenever such condition would be, it would be mentioned in the question itself only. Okay. Okay, so moving to the solution part. Okay, I can see a lot of different answers. Okay, so in general, till now we know that there are total of 128 ways to form two separate lines, right? And of which there are only two ways in which either of the line is empty. So if I subtract those two cases, I'm left with all the cases in which there would be at least one person in either lines, right? So it would be 126 cases only. So in other words, if I delete these two cases, right, this and this, I will left with all other cases in which there would be at least one person in the lines, right? So we know that there were total 128 possibilities. This contribute to one possibility, this contribute to one possibility. If I subtract the two, there will be 126 ways in which I can have a line in which both the lines will have at least one person, right?
Sir, but in question it has been asked at least one person in either line.
Each line contains at least one person, right?
Okay, got it.
Is it clear?
Isn't there is
Yeah,
7
got it,
different
sir.
instances, sir?
Yeah. One by one. Yeah.
Isn't there 7 different instances? For example, if guard put one person in another line and another 6 guys in another line,
Yeah.
so it can be possible that in first line it put the first person, then in second instance he put second person in the first line.
Yeah, there are 7 ways for it, right? 7 ways for this possibility. 1 person in line 1 and 6 in line 2, right? Similarly,
Yeah.
here also 7 ways to
Yeah.
make these lines. And then also there is possibility of 2 being in line 1 and remaining in line 2, or the other way, right? 5, 2.
Yeah.
And similarly 3, 4. So only
So-
thing you, yeah.
Yeah, here's a two person in line 1 and 5 person in line 2. How will we represent it? How will we? How many number of ways? By how number of ways we can arrange it?
How number
We'll
of
have
ways?
to also arrange it. We will
How it comes 7 into
have
6
to arrange
by
it now.
Okay. Let me
this
just
7 into 6 by 2, how it is coming? Like, I don't understand this part.
Yes, sir.
yeah,
I do
this, this part I think will be more clear once we go through the week 6 concept. Okay. So if we go by, okay, let's go by another way for now.
Yes, sir. Can you please elaborate
Yes,
the
sir.
calculation of cases, all the cases, like how can we get 128 by adding up all the cases?
Yes, sir. Yes.
Ah,
Okay, we will.
it's very confusing.
Okay, so this approach involves the use of combination. Okay, so we will do it once the week 6 concept is covered. So we will do it in the next Saturday session, week 6 activity session, right? We'll do it over there. For now, let's use the second approach. You all are aware of
One minute, sir. Arrangement of a person in a line is a concept of permutation or combination.
it will be combination. We'll cover it in next session. Once you go through the week 6 lecture, we will do it by this approach. Okay.
Okay. Okay.
For now, you all aware of
Is
principle
0,
of
7 and 7, 0 counted as a single way, sir?
no, it will
You
be
told there are 7 ways, right, sir?
okay. So there will be cases. Okay. So yeah, for now you are aware of principle of multiplication, right? Counting principles you are aware, right?
Yes, sir.
Multiplication to you are aware of. Okay. So
Yes, sir.
see, in general, you have 7 people, right? P1, P2,
Yes, sir.
P4, P5, P6, and P7, right?
Yes.
Next, there are 2 lines, line 1 and line 2, right? So first person can go to either of the 2 lines, right? He can either go to line 1 or line 2. So he has 2 ways to select the line, right?
Yes.
Similarly, second person also has 2 ways because he can also go to either line 1 or line 2. Similarly, third person will also have 2 ways. Fourth will also, fifth will also, and sixth and seventh will also, right? Is it clear till this step?
Yes, sir.
Yes, sir.
Okay. And it is a simultaneous occurrence, right? It's one after the another. It's not like only P1 will go, or either this will happen or this will happen. It's a simultaneous occurrence, right? All will occur together. Like all the 7 people will be arranged in the line at the same times, right?
This is not something clear.
Okay, see, to form the line, you have to arrange all of these 7 people at the same time, right?
Yes, yes.
So that's what we call simultaneous occurrence.
Okay.
So you will use multiplication rule over here, right?
Sir, in this approach by line arranging method, we can also take person arranging method. This seems so confusing when we go on with 6th week with curriculum, which is like permutation and combination. Then this type of questions seems less confusing at that moment
Yeah.
for solving, because it
Yeah,
seems like if the at first instance when we see the question,
Hmm.
I have approached the question by line by line, line
Yeah,
1 and
yeah.
line 2 approach,
Yeah,
not by
that's how
person
you
approach.
Yeah.
Not by person approach which you are solving right now. So
Mhm.
these
Yes,
this
yes, me
this
too.
creates so much confusion. So
No,
once
you can use by
combination and
either code.
permutation, we will learn that concept so that this question not arise any confusion.
No, it's not like it's the either way you can do. So some people, if you see, will do like that. Even in week 6, you can do questions like that. You
So
need
for
not
now,
necessarily be
we
doing
don't
it.
know what permutation and
Yeah, for
combination
now
is.
you are not aware of this approach. So only approach you know is this one for now, which is the basic approach, basic multiplication rule being used, right? So 7 people to be arranged in 2 separate lines. So in other way, you can see that each person has 2 options to select a line, right? Either line 1 or line 2, either line 1 and line 2, right? 2 options for
So
each.
if we know the formula, then we can solve from the formula of the combinations, right?
Formula of the combination, no, that won't be, both will give you the same answers. Here it will be different
No,
approach.
we can solve that, no, from that. The
Yeah.
way you were teaching that 7 into 6 by 2 is the same answer from the combination formula.
Yeah, but there also you will need to make different cases and then add them all up and reach the final answer.
Okay.
Okay. So in general, there are total of 2 times 2, which is 2 raised to the power 7 base, right? Is it clear till this step?
Yeah, it is
Yeah,
clear when you
yes.
have
Yes, sir.
explained this, but this approach doesn't come into mind. Like every person has 2 ways. Either it can go in first line or it can go in
It
second line.
will,
This approach is not coming in the first place when we see the question. That's my query.
yeah, see, in permutation in week 5 and week 6, you will face this problem constantly if you don't practice enough question. If you keep on practicing enough question, you will have an idea. Okay, this is the approach I can use. I can think of this question like that. So week 5 and week 6 is the part which requires a major of your practice to get your hands on permutation combination. If you solve if you see such more question 3, 4 similar question, then the 5th time you see the same question, you will know that I can approach like that, right?
Yes, sir. Yes, sir.
Okay, sir, let's move on.
So there are 128 ways in total. So within this 128, there are possibility that all the 7 people have selected line 1, right? This is one possibility. In that case, my line 2 will be empty. So this is the one of the cases. Another case would be that all 7 have chosen L2. In that case, L1 will be empty. So these are the only 2 cases in which either of my lines would be empty, right? So that was the second question. There are 2 ways to find when either of the lines is empty. And the third question asked that none of the lines should be empty, or in other words, each line should have at least one person. So the best way to do is to, the total ways, the number of ways in which either line would be empty, to subtract it to get the answer that, yeah, these many cases, my lines won't be empty, right? Also, if you look here, at least one person in each line, I can interpret it as none of the line is empty, right? So these are the things you need to make use of, like what the statement is saying, how you can interpret it. Okay. Is it clear? Still doubt?
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir.
Moving forward. So in this, there's a group of 5 people which decide to join either the sports or heritage team in the college. One can be a member of one and only one team. So if a person chooses to join the sports team, he cannot be part of the heritage team. That condition is given to you. Okay. In how many ways can they join the team? if not necessarily each member of the group joins a team. Okay, so it is also a possibility that a member of the group refuses to join either the team.
So, sir, in this there are three possibilities.
Yeah, that's what we have to think, right? We'll discuss in solution. Do you guys need more time in this or able to do?
Done, sir.
Done, sir.
Done, sir.
Okay, let's do the solution part. Okay. See, so each person here, if you notice carefully, will have three options, right? Either he or she can choose to join the sports team, or he or she can choose to join the heritage team, or decides not to be in any team. For each person, you have three possibilities. So it's for the second person also, you will have three possibilities. For third also, for fourth and for fifth also. So it will be 3 times 3 times 3. It will be 3 ratio of 5, right?
Yes, sir.
So here also you have to form the team, but still you are visualizing the question in terms of each person having the possibilities of joining the team, right? So that's the things you need to think of while approaching the questions. Okay. Is it clear?
Sir,
Yeah.
sir, I got 242, sir. I excluded that zero group. Nobody chose to enter either the group.
Yeah, that's also a possibility, right? It's possible. It is not necessary
Okay.
that each member of the group joins the team. It is a possibility that none of them joins.
Okay, sir. Okay.
So if it has the question be like that at least one member of the group has joined the either sports or heritage team, then yeah, then you can exclude that one case. Okay. Okay, yeah. Any doubt in the first four questions, anyone till now, whatever we discussed?
No, sir.
Sir, in that case, it would be 2 raised to the power 5, right? When at least you have condition given at least one.
Oh no, if the condition is like at least one person has joined at least one, like it is possible
Yeah,
that
so
even one person.
all five persons have two choices, either a sports team, either
No, no,
heritage team.
not all five. See, okay, you have 5 people in the group, right?
Right.
It will be 3 power 5 minus 1.
Yeah. So it would be like all have 3 ways to select, right? Sports or heritage or not to join any, right? Three for each, right? So that was coming out to be 243 ways, right? In the current question, which we have.
Yeah.
Now, suppose if I put the condition that at least one person, it means even if one person do it, it would be enough, right? At least one means joins either sports or heritage team.
Okay, so you are talking about only one person, not all
Only
5.
at least one, yeah. So you have to exclude the case where none of them joins either of the group. So that
it
would be the
will
one
be
case
two.
only. Yeah.
It will be then circle into two.
Okay. So in that, there is only one possibility, right? He refused to join any of the team. He also refused. They all refuse. It is only one possibility, right? So if I exclude this possibility, if I exclude this case, I will have all the cases in which at least one of them joined either sports or heritage team, right? Is it clear?
Yes, sir.
So what if we were not given the last line in the question, like one person joins if and only one group? So would we have considered 4 choices then? Like
one can be a member of one and only one team.
yeah, if we were not given this line, then
okay. So one can be if it is not given, so one can be a member of. Okay, so in that case, you will have another possibility, right?
or both the
he
teams.
joined-
Yeah.
4 cases in total, right?
So that would be 4 to the power 5.
Yeah.
Like generally, when we are given either or in a PNC question, so we consider both the cases in general.
Yeah, if either or means even if both the occurs, it means it is true, right?
Yeah. Like we did in set theory, A or B, we included the intersection part
Yeah.
as well.
Yeah, you include the both because even if both are occurring, it means that either this or this is definitely occurring. Your condition is satisfied, right?
Yeah. Okay.
Is it clear, everyone? Or any doubt?
Sir, I didn't get what you were discussing just before 2-3 seconds back.
Which one? This last statement or the 242 ways?
You were taking either or intersection like that. You used words.
Okay. So what he was saying is, suppose we are saying that either sports team, right, or heritage team, he can join, right? We are saying like that. And if you notice in the question, we have written the last line, one can be a member of one and only one team, right? So he was questioning, but if the last line is not there, so if not last line is not there, then each will have 4 ways. What are the 4 ways? Either they join the sports team, or they join the heritage team, right? Or they join both the teams, or
Both
refuse to join it,
or
right?
neither. Okay, sir.
So
Okay, sir.
another
Next,
question which he raised in this, but if both is occurring, both will satisfy this condition also, either or. So yes, suppose he is joining both
Can you
heritage
mute
team
Joy?
and sports team, both he have joined, then also it satisfies the either sports or heritage team joining, right? If both the teams he has joined, it still satisfies this condition, right? Or if you can say there are two things, A and B, and you want to check if either A or B occurred, right? Suppose this is the question. Suppose both has occurred, then also this condition is true, right? Either A or B has occurred. Even if both are occurring, this condition would still be true. It doesn't mean that only one should occur, right?
Yes, sir.
So that's what he was. Okay. Okay, so that's a simple question. How many 5-digit numbers can be formed with repetition? And you can use the digits from 0 to 9, 0 up to 9. You can use any of those 10 digits you want. Okay, so before moving to the solution part, okay, so suppose this is the number. Is it 5-digit number or not?
Yes, sir.
Okay. And what about this? Is it a 5-digit
It's a
number?
4-digit.
No, sir.
It's 4 digit.
4-digit, right? So you cannot have 0 at the first place. Right? So that's the only thing you need to keep in mind while solving this question. So for the first place, you have only 9 options, 1 to 9, while for the remaining 4, each place can be filled in 10 ways by using the number 0 to 9, right? The total number of ways to form 5-digit number would be 9 times 10 raised to the power 4. Is it clear?
Yes, sir.
Yes, sir.
Yes, sir.
Okay. And again in this question, the 3 steps we have, right? You remember this, the simultaneous, repetition, and order, right? So is it the simultaneous occurrence or not?
Yes, yes, it is
Yes, sir.
simultaneous.
Simultaneous.
Simultaneous, right? Because you need to fill all the 5-digit at the same time to get the 5-digit number, right? This is simultaneous.
And with repetition.
Repetition of digit is allowed. It is mentioned in the question, right? And order, do order matter over here?
Yes,
Order
order
and
matters.
even order matters.
Yes,
It
sir.
is because if I reverse this number, it would be different, right? These two are different, not same. So order do matter. So for any permutation combination question, you can think of only these. If you are able to identify whether it's simultaneous or not, repetition is here or not, and order matters or not, you will be able to reach the final answer very easily. Okay?
So what about replacement?
Replacement, that's the same thing as repetition in another way. Okay. Suppose you have numbers 1, 2, 3, right? So first you picked up 2, right? Let's suppose, and put it over here. Now if you replace it back to its position, again you will have these 3 numbers, right? So again you can use 2. So with replacement implies with repetition. It's the same thing in the other words. Replacement and repetition. It's more or less same. Any doubt till now, anyone?
No, sir.
No, sir.
Okay, so this is the 6th question we have. So Rohit wants to set a 3-digit password for his office desktop. Okay, and it is without repetition, which can be created by following either pattern A or pattern B. And in pattern A, the first 2 digits are alphabetical, and the remaining 1 digit is numeric. And only lowercase alphabets can be used in the password. While in pattern B, the first 2 digits are numeric and the remaining 1 digit is alphabetical. In how many ways can we select the password of type pattern A? So if you look at the pattern A, your first 2 digits should be lowercase alphabet and the third digit should be numeric. Numeric means any number from 0 to 9. So in how many ways can we select password of type pattern A?
It is without repetition, sir.
Yeah, it's mentioned in the question that
Okay, okay.
3-digit password without repetition for both the patterns. Okay, done with it or need more time? Anyone?
Done.
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 6500. Okay, let's see. Okay, so in the pattern A, we know that first two digits are lowercase alphabets. So the first place can be filled in any of 26 alphabets we can use. But for the second place, we cannot use the same alphabet we used at the first place. So there will be only 25 ways to fill the second place. While for the last place, we can use any number from 0 to 9. So there are 10 ways to fill it. So if you multiply it all, it would be just 26 times 25 times 10. Any doubt in this?
No, sir.
No, sir.
Okay. If we look at it. Okay. So for this question, what about these steps? Whether is it simultaneous occurrence to make the digits?
Simultaneous, without
Yes, sir.
repetition, and
Order.
order does
Order.
matter.
All three are right. Yes. No, repetition doesn't matter, right? Without repetition.
Yeah, without repetition.
Okay, moving forward. Yeah. Now you have to focus on password of type pattern B. So in pattern B, your first two digits are numbers, and the last one would be the alphabet, lowercase alphabet to be specific. Okay, moving forward to solution for 2340. Stuff you have answered. So yeah, in the pattern B, the first two digits are to be numeric. So first place can be filled in by using any of the 10 digits you have. So it's 10 ways to fill the first digit. While for the second place, you cannot use the same digit which you used at the first place. So there will be only 9 options available for the second place. While for the last place, you can use a lowercase alphabet, which gives you 26 options to fill that place, right? So final answer will be 10 times 9 times 26. Is it clear or any doubt in this?
Sir, for password, 0 is also allowed at first place.
Okay. Okay. What should be the answer according to you? Should it matter or not? Okay. Suppose I have only numeric password. Okay. I have to make a 3-digit numeric password. So is it numerical variable or categorical? First, you need to identify that, right?
Categorical variable.
Categorical.
Categorical, right? So it doesn't
Yes.
matter whether it has 0 on the first place or not. You can fill it with any numbers. Right?
Yes, yes, sir.
It is a 3-digit password.
Yes.
Okay, so for this question, let's come to, is it the simultaneous occurrence to make the 3-digit password?
Yes, sir. Simultaneous.
Yes,
Repetition
not allowed.
and order?
Yeah, order matter.
Yeah, same as that one, right? Please, sir. Okay, any doubt till now, anyone? Before we move
No,
to
sir.
next question.
No, sir.
So it's
So
the
can you
same.
please explain
Yeah.
simultaneous once more?
Yeah, after this question, we will do
Okay,
that.
sir.
Okay.
Okay, sir.
So that would be a pretty quick question. In how many ways can he select the password for his office desktop? Okay. So he can create either the pattern A password or the pattern B password. And you know the number of ways to select pattern A and pattern B. You just need to identify the total number of ways you can select the password. Okay, moving forward. For zero. Yeah. So total number of ways you can form the password of pattern A is 6500. Total number of ways to form password of pattern B is 2340, and you can select either the pattern A or pattern B, right? So total number of ways would be the addition of the two, which is 8840. Any doubt in this?
No, sir.
No, sir.
No,
Okay.
sir.
Now let's come to this question. So see, you have two options. You can either select the password of type pattern A, right? Or pattern B. Right? This is the password you have to select final. So is it the simultaneous occurrence or not?
No, sir.
No.
Not simultaneous, right? Because
Sir,
either you
but
will
to
select,
get
yeah.
sir, but to get intermediate stage, we use simultaneous.
Yeah, intermediate stage is the different thing. I'm talking about only the password you have to choose, that either it would be of pattern A or pattern B. That's it. Not the total number of ways we are counting. So will it be simultaneous?
No, sir.
No, right? Because either you will choose this or you will choose this. That's all. You cannot choose both at the same time. So it is not the simultaneous occurrence. But when you had to form the password of type pattern A, you need to fill all these 3 digits at the same time. So that was simultaneous occurrence. But when you're choosing the password, you can choose either this one or this one. So this is not the simultaneous. Is it clear?
Yes, sir.
Or another word, yeah.
So it will not repeat as well, but order matters. Does it? Does the order matter here?
It's only the one place we are filling, so nothing to worry about repetition and order.
Then order doesn't matter here.
No, order, yeah, we cannot worry about order and repetition part because it's only the one place you are filling. There is no order, no repetition, nothing, right? It's only one place you can fill either by pattern A or pattern B.
Because there are two things we can't take into account
There is
order,
no
I
order.
guess.
Yeah.
Okay.
So another way you can think, whenever there is a simultaneous occurrence, you use the multiplication rule. And whenever there is non-simultaneous, you just simply add.
Yeah, right.
So it is non-simultaneous because it's not occurring at the same time. Either you will choose this or this. Is it clear, the simultaneous thing?
Yes, sir.
Like, is it
Yes,
like
sir.
we have to consider order into account when it is simultaneous? Is it like that?
Most probably, yeah, you can say, consider like that, think like that. I have to
Okay.
look in more examples for this. Yeah, you can say like that. Okay. The one who was asking to explain the simultaneous thing again, is it clear
Yes,
now?
sir. Yes, sir. So I got it.
Okay. Moving forward, so this is the last question for today. You need to compute the following expression. So it tests whether
Sir,
you are, yeah.
in previous questions, sir, but
Yeah.
in case of the combination, order doesn't matter, but the events happen simultaneously, na?
Yeah.
So order has no role in a combination.
So in the previous thing, there was only one thing, right? For only for one thing, but how would order and repetition will make a difference?
Yes.
That's the point. Okay, so yeah, that's the last question. It tests on factorial. Let's wrap it up.
Sir, we have to answer on chat box or on peer decks.
A peer deck.
Oh, sir. Some of guys are putting answers on chat box. That's
But you're not sure if they're right or wrong. Let them write. But if you put it on peer deck, it would be helpful for us also to get an idea like which concepts you are grabbing or not.
yes.
Okay, let's move to the solution part. Okay, so 2 of you have answered 0. In 0 factorial is 1 only. So as we know that 10 factorial, we can write it as 10 times 9 factorial. Just it's the whiteboard. 10 factorial times. So you all know that value of 0 factorial is 1, right? And value of 1 factorial is also 1. So 10 factorial, you can write it as 10 times 9 factorial. Right? Let 5 factorial be as it is. 0 factorial is 1. 9 factorial times 1. So you can cancel out 9 factorial over here. So you are left with 10 times 5 factorial, which is nothing but 10 times 120, 1200. So 5 factorial, we got 120. So 5 factorial is nothing but 5 times 4 times 3 times 2 times 1. Right? Is it clear?
Yes,
Run
sir.
it out in this. So that's what we have done over here. Okay. So any doubt in these slides? Anyone?
No, sir.
Well, I have a problem for practice assignment.
Okay, we can do this assignment now. Okay. Okay. Which practice assignment?
So,
Okay. So we all will be having this. Every time you refresh, you will get a new set of question in this.
yeah.
Can you tell me the question statement? You know.
It's 1 minute. Yeah, an Alzheimer's patient has to take medicine thrice a day. She needs to take 1 blue and 1 black pill
Okay. Yeah.
in the morning, 1 green and 1 yellow pill in the afternoon, and 1 blue and 1 black pill in the evening. She doesn't know what color pills to take, but knows that she needs to take 2 pills, different color each time. Assume there are infinite number of pills of each color. In how many ways can she take the pill in a day? Order of taking pills doesn't matter. That is, she can take first blue pill and later black pill in the morning, or black pill first or blue pill later. This one.
This is the question, right?
Yes.
Okay. So in general, if you notice how many pills you have blue colored pills, right?
Yes.
You have black colored pill,
Yes.
green, yellow. That's all 4 different colors you have, right?
Okay.
So in general, you have 4 different colored pills.
she have to take 6 different pills. So we should consider six pills. Okay, different pills. But here they are considering 4.
But because there are only 4 colored pills, right?
Okay, different colors. Okay.
I'm just talking about the different colors. There are only 4 different colored pills in general, right?
Okay.
So the blue and black pill, the same pill she has to take in the morning and in the evening, right?
Yes.
So in general, but she knows it that she has 4 different color pills, right?
Yes.
Out of which she needs to take 2 pills, different color. That's all. So according to her, the equation would be she has 4 different colored pills, of which she needs to take 2 each time.
Yes.
Right? And in a day, she has to take 3 times in general, right? One in morning, one in afternoon, and one in evening, right?
Yes.
So next the question to, in how many ways can she take the pills in a day? Order of taking pills doesn't matter. Okay. So let's consider the morning dose.
I have a problem with I can't visualize that how to do this sum. That is the problem. Sorry.
Okay, so you couldn't understand from the statement, but
Yeah, I
the question.
understand the question, but problem is that how to do this one. Like, while doing this kind of sums, you have to make some visualization, or you have to make some like in some questions I have to make boxes so that I can place some like that. But here I couldn't understand how to.
Same issue with me also, sir. When we see the solution or when we see the explanation, we got everything right. We got the question, we got the solution, how it is approached and all. But when we see the question for the first instance and when we try the question, we don't know, like as the Mathri said, we can't visualize like how to approach this.
There are some questions which we
Yeah,
can't
in some questions, for example, the slides which you have presented today, only the last and first questions are like which I can solve it, but these the line question which security guard has to arrange lines, that questions I cannot visualize, like how to approach this and how to solve that in that manner. But when we see the solution, I got your point, like yeah, it can be mannered if you have to visualize, like one person have 2 choices, either it will go in line 1 or it will go in line 2, likewise. So yeah, that is problem with me also.
So see, these things basically comes with the more question you practice, the more visualization you will build up in this. That's the only problem I think with permutation combination.
I have tried practice assignment 2-3 times, like refreshing and get another question paper, still same issue. I don't know why. But when we learn the permutation and combination in the next chapter, I think we can solve this a bit easier, or I am wrong.
Yeah, you will be, because in that time you could have practiced more questions. You would be practicing more questions,
okay,
and also
so in that
using the
manner we can solve.
Yeah, in that way you will be able to solve these questions. If you see the similar question again, I think you will be able to solve it pretty easily, but you know how to approach. Okay, so let's try to visualize this one now. Okay. So person has to take, think we can run a jam for super.
There is also another question was giving that I missed that one. There is 1,000 number between 1 to 1,000. You have to find out 3, 6, and 9 digit, like that kind of question. I was trying to visualize.
We will look into that. Okay, so for now, okay, if we read the question statement, right? So for first, what does the first statement say? That an Alzheimer patient has to take medication thrice a day, right? So consider in a day, right? She has to take medication 3 times. This is the medication 1, medication 2, and medication 3, right? Okay. Moving forward, she needs to take one blue and one black pill in the morning, right? So what she's trying to say is that your first medication is in the morning, right? And you need to take blue pill and black pill, right?
Yes.
Okay. Then moving forward, statement, one green and one yellow pill in the afternoon. So your second medication is in the afternoon, right? Where you will take one green and one yellow. Okay, so this is your afternoon. Okay. Green pill, right?
Yes.
And yellow pill. Okay. The next statement it says is, and one blue and one black pill in the evening. Okay. So for the evening part also, you will have blue pill and black pill, right? Okay. So these are the 3 medications she has to take. Okay. Now she doesn't know what color pills to take, but knows that she needs to take 2 pills of different color each time, right? So what happens is, in the morning, she doesn't know which pill she has to take. All she knows is that she needs to take 2 pills of different colors, right? So first we need to get an idea of what is different color.
Blue, black, green, and yellow.
Different color pills, right? So what are the options she has actually? Blue is a different color, right? Then black is also different. Then green. Then yellow, right?
Yeah. Yes.
And then blue and black we have already written. These are not different ones, right?
Okay.
Okay. So each time she needs to take 2 pills. Okay. In how many ways she can take the pills in a day? Okay. So for the first medication, right? In the morning, she needs 2 different color pills. So she can choose any of the one color of these 4, right?
Yes.
So 4 ways to select the first pill, right?
Yeah.
Suppose she selected
And
blue.
second one should be 3 ways. Oh.
3 ways, right?
Okay.
But here, if you notice,
Yes.
order of taking pill does not matter. So it is given that order doesn't matter, right? So in this case, if you will try to make these 12 possible ways which you are saying, okay? So let's make it. Okay. I am denoting blue by capital B, okay? Black by B1. It is by G and it by yellow, okay? So the 12 possibility which you will have is, I think I will be able to write it. Okay. See, so the first possibility would be B1, right? Second would be BG and third would be BY, right?
Yeah.
Then fourth one would be
Black and blue.
B1B. Yes. Black and green. Sixth would be black and yellow, right?
Okay.
Similarly, seventh would be GB, then GB1 and GY, right?
Yeah.
But sir,
Yeah.
the first row as a B, you have written B and B1, and the second also you have written B1, B. These are the same thing, no, sir?
Yeah, I will come to that only. For that, I have written these 12 cases. So now see, we are know that order of taking pill doesn't matter. So this case is same as this one, right?
Yes, sir.
Same. Similarly, this one is same as this one, right? So in general, what is happening is every case is counted twice, right? So we need to divide it by 2, or need to subtract the duplicate ones, in other words, right? So there are 6 ways to take medication in the morning, right?
Okay.
Now when she comes to the afternoon medication, again she can choose 2 different color pills, right?
Yes.
Again 6 ways, and again for the evening she will have 6 ways, right? So morning she has 6 ways, afternoon she has 6 ways, evening she has 6 ways, right? So, and it is the simultaneous occurrence for a complete day medication, all 3 should occur, right?
Yes.
Together. So we will use multiplication. That's 216 ways, right?
Okay.
Now is it you are able to visualize side by side?
Yes, sir.
Is it clear, right?
Yes, sir. Thank you, sir.
And what was the other question you're referring to?
Because I just lost that one. It was said something between 1 to 1000. I have to find out the number, those numbers which ending with 3, 6, and 9, and those numbers I have to find out. That was the question. But I missed that one. I lost that one because also given in the practice assignment.
I think I might tell you. Okay. There were 0 to 1000 you have to make using digit 0, 1, and 2.
Yes, means I have to find out like within 1 to 1000. That is the limitation. Within 1 to 1000, I have to the numbers. I have to find out the numbers which end with 3, 6, and 9. Hence, at the end, I have to find out the number which is ending with 3. I have to find out the numbers which is ending with 6. I have to find out the numbers which is ending with 9.
Okay, give me a minute. Yeah.
Sir, one question is also there. NCR is equal to NPR if situation is given and we have to choose either true or false.
What thing? NCR and PR?
Yeah, the question says if NCR is equal to n factorial upon n minus r factorial into r factorial and NPR is equal to this, then based on this information, which of the following is are true? So we don't know what NCR and NPR is because we don't have studied permutation and combination yet.
No, but you know how to open it, right? Ma'am has told it in the lectures.
Sir, in the question,
Yeah, it is. We can open there that n factorial part, right? But we don't know what NCR and NPR is. Ma'am doesn't explain NCR and NPR in the lectures. Is question number 4, practice assignment 5.
It would be different for us.
Yeah,
okay,
yeah.
I will check it. Okay. Okay, so 1 to 1000 and we have to find. Just tell me if you spotted question.
Okay. So before.
Yeah.
Wait, what is
Could be in this. Voucher.
Yes, sir.
This was
Fifth
the
question.
question,
Yes, yes, this one.
The-
What is NCR
okay.
and NPR?
It is given, right? NCR equals this.
And NPR is equal to that, and we have to
Yeah.
evaluate it on that basis.
Yeah. It's just a simple factorial calculation only.
Got it, sir.
So why can't these questions be given in a single assignment? Why
Because
they?
we have a good bank of questions. If you see 30 questions in a single assignment, you won't be attempting it for sure. That's why you give 5 to this refresh. if
And
you
it
want.
will also helpful in revision.
Yeah.
Just refresh and get new set of questions and solve it.
Sir, can you repeat that NPR thing, sir? I didn't get it. I mean, I didn't
The
listen
thing
to
which
it.
I was saying is that formula is given. NPR is equal to this. Okay. And NCR is equal to this. Then you need to check these
Okay.
relations.
You
just
have to
simply
put
need
values.
Values and do the factorial calculation.
Okay. Okay. Okay.
But
Sir, another thing, just a doubt, sir.
yeah.
If we learn permutation combinations in 6th week,
Yeah.
can we solve all these questions without the use of this multiplication and addition, sir?
Yeah. Most probably you will be.
Most probably. Right, sir.
Is this the question?
Yeah, it is kind of this one. Kind of.
I think it's ratio 1, right, Maitri?
Yeah, this one. This is gone like it's kind of like that. I just don't remember how many digits I have to form. That I just forget. Otherwise,
This is
I remember the exact thing. I just forgot that how many digits I have to form using that information. That I just forgot.
oh, just when you find the question, just make a note of it. The next session on Saturday, I will be taking it. We will discuss it.
Okay, so I will also try. If I get a question, then I will screenshot that question and I will put it.
Yeah. And also just read line by line and try to interpret what it is saying. Okay. Then I think it will be able to more visualize it.
Yes. So,
Yeah.
so means like more than means strictly greater.
Yeah.
So
Simply.
week 5 tutorial
Yeah,
2.
there is an error in that explanation. It should be only 5
Yes, sir.
letters
Just
that
want to
should be considered.
Yes, sir. Okay, thank you, sir.
Okay, guys. Any other doubt? Shall we close?
No, sir.
Okay, guys. Thank you, everyone.
Thank you, sir.
Thank you, sir.
Thank you, sir.
ఏం అట్లా అంటావు పాపం